Okay, so we're looking at chapter 3.3. Well, actually, chapter 3 total. Would you go to page 81 in your textbook? Because that is the summary, the study guide for chapter 8, or chapter 3. Oh, my brain. There you go. Page 81, chapter 3, study guide. And let's talk about just some definitions first. Are you with me? What's the equation for acceleration? How do I define acceleration? Simple equation. Meters per second squared is the units. Okay, I'm cool with that. Velocity over time. Good. And even the change in velocity over the time. Are we cool there? And you can say change time. Your textbook has that. I tend to usually not put the change there because usually time we start off at 0. We don't usually start off anything other. But if you're looking at a graph and you're going from 2 seconds to 4 seconds, okay, yes. You subtract final minus initial.
Are those triangles like deltas?
Deltas, yes, sir. Change it.
So it's delta V over delta T.
You got it. And those deltas mean velocity final minus velocity initial all over time. Final minus initial. Delta always means final minus initial.
Okay, so wouldn't it also be the same for the time then?
Yes, I just usually don't write it because we don't have it much in the equations. We just use t. We just use t. Okay? And again, this is acceleration. Right? We cool? Okay. So and this is just simply, this equation is just expanding the deltas. Right? And making it final minus initial. So the next equation that's listed there on page 81 is they simply just took this equation and instead of it being solved for A, we solve it for VF. So we said that VF is equal to what? VI plus AT. Good. Okay? Again, this is just the second equation that's there on page 81 I'm looking at. So are you comfortable? We simply just move this around, right? We just solved it for VF. That's all we did. And of course, V stands for what?
Velocity.
Velocity. And what units does velocity have?
It's distance and time.
Cool. But what's the units?
Oh.
Meters per second. Whew. I'm telling you, friends. It can be, sure, it can be kilometers per hour, it can be miles per hour, right, but it's distance divided by time, right? I'm encouraging you guys, your textbook doesn't say the acceleration is 3.4, the velocity is, they just give you numbers, right? And you have to know based on the units what number that is, what it means. Okay, so that's velocity. Your textbook in 3.2, if you want to flip over with me to page 71, there's a nice graph there that looks something like this. So a graph like this. We have this car that's accelerating, and we want to calculate the displacement, right? And we know that if I have a velocity time graph, displacement or distance, how far you traveled, is the area underneath that, right? And we can calculate that area just by using 1/2 base times height, right? Simple triangle geometry, right? But if that car is already traveling at a certain velocity, we have to also include the area underneath that triangle, right? A classic example would be Sean coming to school. He's driving 55 miles an hour and realizes, oh wait, I can go 70 on this road. And so he speeds up from 55 to 70 miles per hour. If we just calculated how far he traveled because of that acceleration, we would miss out on a lot of miles because he was already going 55 miles an hour, right? So we have to calculate that whole area to get how far he traveled. Does that make sense? And in order for us to show that in this equation, that's what this next equation there, again, back on page 81, is showing you, this distance equation, that they call it xf. The distance in the x direction, final. xf is equal to xi. In other words, did you give them a head start? Did they start out already 10 meters away? Plus vit. The vi is the initial velocity. What point, how fast was Sean going when he started? He was already going 55? Okay, that's my initial velocity. And then how long were we going there? Let's say this is 10 seconds. Okay, that's 10 seconds. He was already at 55. Are you with me, friends? Okay, so that's what this piece is giving you, that VIT. And then I need to get this 1/2 base times height, right? But because this is velocity and time, if I make it instead into acceleration, it becomes 1/2 AT squared. And your textbook rolls through in 3.2 how they derive that. Those of you who are calculus or pre-cal folks, you can derive all of these equations just simply from the acceleration stuff. We won't do it in this class. But I'm just saying you wouldn't have to memorize all these. You can simply derive them if you want to. Okay? It's all there. Acceleration, velocity, and displacement. Displacement is distance. What units do we get for distance? Meters. Okay? One more equation here that's on the bottom of that page. It looks a little bit different than the other ones. It's another velocity equation. It says that, well, let's go blue. It says VF squared equals VI squared plus 2A XF minus XI. So what am I trying to find here? What does VF stand for again? Final velocity. Okay, so this is another velocity equation. So how do I know which one of these to use? Is there something different about that bottom equation that is different than the other three equations? There's a squared. Cool. All right. Well, I like that. Okay, it has the displacement in there, right? The XF and the XI. Good. What is it missing? There's no time. And that's the key part I want you to hear. That bottom equation, if you don't have time, let's say you're standing, let's say like number 44, where you're standing up on a window and you drop something 3.5 meters. How fast is it going when it hits the ground? Okay, well, how do we know how long it's traveling? It doesn't matter. We don't need that. If we know how high it was, right? It started at 0, it went 3.5. It had no initial velocity. In other words, you didn't throw it down, you just dropped it, right? And we know that you're dropping it on the planet Earth because the planet Earth has acceleration that's what? Gravitationally. 9.80 meters per second. If I know those numbers, that's all I need to solve that problem. Does that make sense, my friends? And the key, the whole key of this piece is, and I get your question 1 second. The whole key is that they're going to give you a bunch of numbers and you got to figure out what letter do those numbers go to. And does that like you just magically guess? No, you look at the units, guys. If it's a meters per second, it has to be a velocity. If it's a meters, it has to be a distance. They may use X or Y. X means horizontal or Y means vertically, but they both mean distance or displacement. Okay? Yes, ma'am. Oh, please. And I'm recording it right now as well. Yep. This is in whiteboard form. That's in. Any questions there? Okay. What I'm going to encourage you to do then during this class period, I know many of you have individual questions you have to ask me, maybe about assignments or about these kind of pieces. Sorry, let me stop this recording.